This is Dr. Indradeep Kumar, Assistant Professor IARE, Hyderabad. So in this video, we will see problem on structural loading. So if loading is there, that already we had seen some unit load method. Okay, so in that also I discussed everything, all the derivation will be there. So now we will apply that concept here. So topic will be covered in this video is numericals on structural loading. Okay, so this is the question. This type of figure already also I showed you there where P1 load is acting, P1 at point A, point C. So the same way we have to solve. So see the question. Calculate the vertical deflection of the point B. So that is here we have to find, and the horizontal movement of D at this point. That horizontal movement of D, right? In the pin joint framework shown in the figure. So figure is there here, pin joint. All members of the framework are linearly elastic and have cross-sectional area. So just see all members having the linearly elastic and have cross-sectional area same. So cross-sectional area is same. Earlier also in video in previous video I told you, if cross-sectional area and E is same, then you can just keep common. If it is not same, then you have to take separately. So here they given, just to reduce the course, or you can say simplify the question, they given the same cross-section area and same E of the material of the member is this one. This E of all the members are also same. So this 1 by E is 1 by A, E is common for all or constant for all. Right? Now the question is what? We have to find deflection at B and deflection at D. So first what we have to do? First find the supports. Right? In previous video also we had seen, first we found the supports. So first we will find the support reaction. Then next what is the step? Then force in each member. How many members are there? Like suppose you can just write, I will show you in the later that table how you will find, or that you can keep like me AE, AB, EB, EF, BF, then BC, FC, CD and FD. Like that member name. Then next you have to what? So just see here. The length is given and first force is here acting at 40,000 Newton. Here force is acting how much? 1 lakh Newton, or you can say 100,000 Newton. And the distance between this is given 400, 400 and 400 mm. So this also is 400 mm. This is 400, this is 400. So it's a isosceles triangle. This is what? That we have to find this length. So either you can, this is the perpendicular, right? So you can just apply the Pythagoras theorem. So this square plus this square will give you this square, right? That you can find, so that you will get, I'll just see here, 400 square plus 400 square equals to E square, right? After adding these two, right, taking a square root, you will get 400 root 2, or you can just apply the sine 60 cos 60, that vertical also, right? So this will be 400 root 2. This also will be 400 root 2. Right? So now we have length of all the members, right? And then members name also. So just see here first the table. Here. So just see how many diagonals are there. This diagonal, because same length is there, so this diagonal also will have 4000 root 2, 4000 root 2, and for this also 4000 root 2, remaining all 4000. So now first see the table. So first here, first column. So this way if you will make the table column, then it will be easier to find. So just here, first member is the name of the member, that AEF, whatever I said. Then next we found length of each member. In that only these three requires to find. Remaining all are directly given. So that diagonal one, that is there. Now we have to find force in each member. So this is only the lengthiest part what we have to do here. Remaining all is very easy. This also we can find easily by putting the fixed load. And then these parts are not that much linear. The only thing is this part, that third column is time taken. So first what you have to do, we have to find forces in each member. Okay, so I will show you how to find. For that, in our previous one, you can see the joint method and section method. For solving the structural problem, two methods are there to finding the force. Okay, first name is joint method and second method is called as the section method. So here I will show you by the joint method how to solve this one to find the forces in each member. Okay, this formula you know the deflection for this what you have to find deflection. So now what is there? A and E is common for all. So that's why A and E is out of the integral. So A by E is out of the integral. So now what is left? I equals to 1 to K. How many numbers are there? Fi Li by del Fi by del P. Means what we have to do? First we have to find this Fi. Li already we found. And then this del Fi by del P. For B it will be del PB. For D it will be del PD. After finding this, just add all. Means find for all the members. Then add all the members. You will get this delta. Okay. So now first we will find the forces, and before that we have to find what? The support reacts. So just see here. Finding the support reaction. So how much weight is acting here? So this is RA. RA is acting upward. So RA plus RB minus downward. So this is 40,000 and this also is acting downward. So minus 1 lakh, that is equals to 0, or you can say RA plus RB equals to 1,40,000. Sorry, 1,40,000. So one equation we got. Now what we have to do? Apply the moment. Take about a new point, right? So just take moment about A. So RA into 0, right? Then plus RB into how many length is there? 400, 400, 4,000, 4,000, 4,000. Total 12,000. So into 12,000. This one. That is equals to or minus of this one. So equals to 40,000 into 4,000. So 40,000 into 4,000. Okay. Then plus, because equal to that directly we are taking. So now this time 1 lakh into this total 8,000. So 1 lakh into 8,000. Right. After simplifying, you can see that RA will be 0. So RB into, okay, that 12,000 equals to just here 4 4 just 16, okay, and then 4 and 3 70, okay, plus here okay, so 80 into, so 8 and 5 380, so 3680, right? After adding all, so just here 4 and 370, so 3 2 5 6 7, okay. So this will give you how much? 96 and 5, sorry, 60. Okay. So after this, what do you get? RB equals to 12, sorry, this one, 9 6. So let's see, instead of this, you can directly take this as 40 kilonewton also and 100 kilonewton also. This you can take as 4 meter, 4 meter, 4 meter. But all are in mm. So I'm solving this similar equation. You can see in the book that is there. They have taken the 40 kilonewton. So let's see, because this is 96000 divided by 120000. So this will get cancelled, right? 12 8 is 96. So from here RB equals to 80,000 we will get. Now put here. So RB equals to, so now I'm just removing this one. RB equals to 80,000. Sorry, this is RD. So RD equals to, this is RD. Right. Now after putting here RA plus RD is 80,000 minus 1,40,000, right? That is equals to 0. Oh, sorry, this equals to, so RA equals to 1,40,000 minus 80,000, that is 60,000. So now we have this as RA 60,000 and RD, that is 80,000. 60,000. Okay, now we got. Now we have to find these forces. Okay, so now let's see how we'll find. We will apply the joint method. Okay, so just we have to use the free body diagram of that. Whatever the point we will consider, that how many forces acting, all the forces we have to keep there, and then resolve that forces if all the forces are not perpendicular and horizontal, means vertical and horizontal. And once after resolving, just take sum of all the vertical forces equals to 0 and sum of all the horizontal forces must be equals to 0 for the equilibrium condition. So just see what we are taking. So at like this you have to write at point A. For each point you have to find at point A till you will find all the members. At point A, what is there? So this is here that RA is acting, right? And one is here. This is RA, and one is acting this like this, right? So this is point A. This is E. This is B, and RA is acting here, right? Now just see here, or let me draw the bigger diagram. Like this one is RA, right? This is point A, this is E, this is B, right? RA we know, that is 60,000, right? Now just see from this figure what you can see, this is isosceles triangle. This angle is 90 degrees, so this will be 45, this will be 45, right? So just we have to use that one. So this angle is 45. Now this is horizontal, so no need to do anything. This force is vertical, no need to do anything. Only this is inclined, right? So this we have to resolve to vertical and horizontal component. So let's take this as AE force. Okay, so now we are resolving horizontal and vertical. So when you will resolve, we are going A to E, right? So this should be in between that result. So AE, this will be F AE. So this is a vertical one. So sine, how much angle is there? 45 degree. And resolving of this one is what? F AE cos 45 degree. Right? Now we resolve. So now just see all the forces are horizontal or vertical. So now from here you can see I'm just taking the first vertical. So for the equilibrium, sigma F vertical, that is equals to what? It must be equals to 0. Right? So sum of all, just see these two are acting in the same direction, right? Just upward. So just see here, F A E sine 45, right? Plus 60,000, this is 60,000, that is equals to 0. So from here, what we can say, F A E sine 45 equals to minus 60,000. So F A E is what? Minus 60,000 divided by sine 45. What is sine 45? 1 by root 2. So after putting here, what we will get? FAE equals to minus 60,000 divided by 1 by root 2. That will give you what? FAE as minus 60,000 root 2. Now check the table. FAE minus 60,000 root 2. Okay. So now this one. So sum of horizontal component, oh sorry, I just removed this one, okay, I will draw again. Sum of vertical component we found. Now here what we had, this we resolved, this is AE sine 45, right? This was force is acting first AE, that FAE cos 45, and one force is acting which one? FAB. Right, so both are acting in the same direction. So just we have to put that one. So sum of force, that horizontal force is equals to 0. Right, just put the value here. So FAE cos 45 plus FAB equals to 0. So from here what we can write, that FAB equals to minus of FAE cos 45. You know the FAE value, you know the cos 45 value, just substitute. You will get the value of FAB. So just see here, what is FAB? We are finding FAB now? FAB or FBA, so just here, that is 60,000, right? Just see, just substitute here, FA, so minus of minus 60,000 root 2 into cos 45 1 by root 2. Root 2 cancel, minus minus become plus. So FAB equals to what? 60,000. Now let's see here, FAB and FBA, don't get confused with that one, because we are finding FAB and here you can see in table it's a given BA, right? So once we will apply the forces, right, like here in this, if once compression will be there, that arm will have the compression only, not elongation, because simultaneously both are not possible. If it's getting extended or elongated, then only elongation, and if it's compression, then compression. Like FAB, you will take that's compression, then EA will also have the compression only. If suppose AB is expansion, then BA will also expansion only. So AE, what we got? Negative, minus 60,000 root 2. So minus indicates only it's a compression, means what we have chosen the direction that is opposite to that one, means AE we have chosen. So the direction of actual force acting is from E to A, not A to E. So that negative sign only shows just either it's a compression or elongation. If it's negative, then it's a compression. If it's getting positive, then it's elongation. So now this we got the negative, so AE is getting compressed, and AB we got the positive, so AB getting elongated, or AB experience the tensor, right? So don't get confused here with the negative and positive sign. Just that is just for the to check it's a compressive force or that tensile forces acting on that member. Okay, so now we got these two. So see, always remember what you have to take. Their maximum two unknowns should be there. Then only by two equation we can solve that sum of vertical forces equals to 0 and sum of horizontal forces equals to 0. So just choose such point where only the two unknowns are there. More than two, then again it will be difficult. Then you have to take the moment, and for this type of a structure, taking moment it will be difficult. So choose such points first which having two unknowns only, right? So now just see here, we found this one. If we will go with this point, right, just I'm saying here, this only we know. This is unknown, this is unknown, this is also unknown. So three unknowns are there. Means this point we will not take, right? So now here, and this is also unknown, this is also unknown, this is also unknown, right? So this point also we cannot take right now, because those two unknowns are there, and this is because this also is unknown, right? So then what is there? Here you can see this we know, right? This only is unknown, and this only is unknown, and this point, right? So now we will take at E, at point E. Okay, so now just see, same draw. This is E, right? So here one force FEF is acting, right? This is what? FE or BE or EF. Just again don't get confused with EB or BF. Whatever the direction you will take, if it's getting opposite sign, then it's you will miss your direction is wrong. Suppose we are taking right now BE and it's coming negative, is the actual force of direction is E to B. That's all. So don't get confused with the negative and positive, which negative value is coming and positive value is coming. Just choose your direction. If that value is coming positive, then your chosen direction is correct. If it's coming negative, means the force is acting oppositely. That's all. Okay. So now this is there. So this point, this we know. That is minus 60,000 root 2. Right. So now what we will do, this is only the vertical. So this way, what? Just resolve. So again, same thing, how you will resolve. So just see here. After resolving, this should be inside. Right. So one in this direction, the other one will be in this direction. So this will be FAE cos theta, and this will be FAE sin theta. Right. This over. So this already FAE we know. So here from this again horizontal, so FAE we are putting minus 60,000 root 2 cos 45, that is opposite, this is equals to F of EF. So from here you will get EF. Similarly for vertical one, vertical both acting in the same direction. So FAE, that is 60,000 cos 45 plus FBE, that is equals to 0. From here you will get FBE. Now that FBE is known, this also is known. Now just see, now we can take this point, that B, because now this is known, this is unknown only, and this is unknown, right? So now similarly at point B. So now just draw the B. So this is here, here, and this is, right? So this is B. This we know, right? Now this is unknown, this is unknown. So just let me see that what is the EB value. EB is 20,000, right? So put here, this is 20,000 EB. Now here this is what? BF. So again resolve this one. So one will be here F, BF, right? Sine 45 and FBF, sorry, cos 45, and this is what? FBC. Again horizontal and vertical. So from here you can see both are acting in the same direction, the vertical. So sigma FB equals to 0. So 20,000 plus FBE, sorry, FBF, this is FBF. So FBF sine 45 equals to 0. So from here FBF equals to what? Minus of 20,000 divided by sine 45. So this will give you minus 20,000 root 2. We have FBF. From here what we can say? FBC. So FBC plus FBF, right? Now we have FBF. So FBF cos 45 plus FBC equals to 0. We just got FBF. So from here you can say FBC equals to FBF cos 45. So root 2 will get cancelled. So whatever value you will get FBF, same will be for FBE. Here, BF, right? So minus 20,000 root 2. And then BC is, yeah, BC, so FBC is, yeah, that 80,000. Okay, so now CB we got. So now we have this also, right? So now you can take either any point. You can take this point also because this is unknown, right? Or take this point because this already we know. The same way you can find here. So this is 80,000, this was 60,000. So this becomes 60,000 root 2. So this is 80,000, means this will be 80,000 root 2. Now you know this one. From the same, you can find this. Once you know these two, only this is left. That by using this point, you can find this one. Hence, all the forces you can find. This method is called as what? That is joint method. Means just considering the joint, resolve all the forces in vertical component, horizontal component, and then equate sum of all the vertical forces equals to 0, sum of all the horizontal forces equals to 0, and solve for that forces in that. That means after that you will get forces in each member. So this is only the lengthiest method of that process you have to find. Once you know that forces in each member, after that it becomes easy. Just you have to apply the energy method. Okay, so this already we discussed. This is the deflection formula for this one. Now here A and I is what? Same for all. So AI, EI instead of AI, EI, directly we can keep common that AE. So 1 by AE, this one. Now we Fi, Li, and dou Fi by dou P. That dou P is deflection at that point. Means here for finding BF, this will be del PBF. For finding at D, this will be del PBF. Right? So just see here the table. Right? So now first what we have to find this force FBF. What is the energy method? Just remove all the forces and apply the force at that point where you want to find the deflection. So once you will find the deflection, you will get this one. So just see here for the formula finding FBF. Here what is FAJ? J stands for that particular member, like first member, second member. Okay, just see here. Like if here AE is J, EF, AEF, for which member you are finding, that is there. So actual force, how much is acting, what we found, right? FB, what is that? That is the fictitious force, virtual force. V stands here for virtual forces. And LJ, length of that member, EJ and AJ. So EJ and AJ is constant. So just you can keep out. So here this will be 1 by EA sigma I equals to 1 to J F A, right? That actual J into F virtual J plus LJ. Means what? Actual force acting in that member, then virtual force acting in that member into length of that member divided by EA. Right? Like that you have to find. So once you will have the FE, just see this EA is not required right now. That we can later directly we can take common and we can directly put here. So see here, simply this FBF. From here we can find FBF in terms of EA. Okay? By using this formula, and here you can say the 1 by EF into these value will come. Here also, now next, what is the condition? Once you will find this one, then differentiate with respect to what at that point what fictitious load you applied. So for finding B, let's taking first B. So at B, what we are applying the forces, fictitious force PBF, and just here at this image, at this we are applying the fictitious force PDF. So first finding PDF means this is BF. Similarly, by the same we can find FDF. So you can see the FDF all only this because the horizontal deflection is there. Horizontal deflection is there. So only this force will cause, remaining all will be 0 only. So because of this, the FAB, BC and CD only will be there, and because of that only you have to find the fictitious force, that FDF. So this is the FDF. Just here only for DC, CB and BA this will be there, right? So now next is what? Differentiate with respect to, for finding PBF, differentiate with respect to PBF. For finding deflection at D, differentiate with PDF. So now for finding B, first we will find B. So for finding B, this equation, that is FBF, differentiate with respect to what? PBF. So after differentiating here, what we will get? Del FBF by del PBF. So here wherever PF is there, PBF, that becomes 1. Remaining everything will be there because with respect to PBF we are differentiating. So differentiation of minus 2 root 2 PBF by 3 will give you minus 2 root 2 by 3. Similarly, minus 2 PBF by 3 will give you what? Minus 2 by 3, because differentiation of PBF is 1. So minus 2 by 3 into 1 is 2 by 3. Then differentiation of minus 2 2 PBF by 3 will give you minus root 2 by 3. Similarly, PBF by 3 will 1 by 3, PBF by 3 1 by 3, 2 PBF by 3 2 by 3, 2 PBF by 3 will give you 2 PBF. So means just you have to differentiate this full column with respect to PBF. So now we have del FBF by del PBF. Now this is for del. So this is 0, so already 0. Differentiation, this with respect to DF will give you what? 1. Differentiation of this with respect to DF, 1. This also 1. So this will be 1. Now we found. Now the thing according to the formula, what is there? Just see here the formula. What is required? Fi, Li and dou Fi by dou P. So according to our condition, what will be delta B? Delta B will be equals to sigma I equals to 1 to K, that here 1 by AE, right? Fi, Li into dou Fi by dou PBF. This is for delta B. And for delta C, this will be 1 by AE into sigma K equals to 1 to and 1 I equals to 1 to K, whatever, del Fi by del FD. Sorry, del PFD. Right. So let's see here. First, what you have to multiply? Fi into Li into this one. So this is which column? So let's see here. Here. This and this 2, 3 and 5. Multiply 2, 3 and 5. You will get this one, right? 2, 3 and 5. Just see FL del FBF by del PBF. FL this one. So 2, 3. 2 into 3 into 5. Multiply for all. You will get this column. This is for delta B. Okay, so this is 2 in 3 into 5 column number. I'm writing this 2 3 5 is the column number, right? Column number 2, column number 3, column number 5. For finding D, same 2 into 3 into this time 7. So column number 7, because column number 7 is only del F df by del P df. So then multiply with this one. So after multiplying 2, 3 and 7, you will get this column. So just see, once you will multiply now, after that you can see this will be power of 10 to the power 6 will be there and these value will be there. So instead of writing here, this column becomes the bigger in size. So directly kept here into 10 to the power 6. And this value is, this is actually after multiplying these two L, F and this one. Right? You will get 320 root 2 into 10 to the power 6. So in all 10 to the power 6 will come. So directly we can take in common here and 10 to the power 6 means this value in the range of 10 to the power 6. Similarly here also that will be of 10 to the power 6. Now next, what is the formula? Just see sigma of all the members, right? So here just see why the tabular is required. Now instead of doing the long addition and all, right, just add here, right? You will get this one after adding this 1268 into 10 to the power 6. Once you will add this, you will get this one. So once you will have this, now next what is required? Divided by AE, right? Just now I wrote divided by AE, right? So after adding 1268 divided by A into E. So 1268 into 10 to the power 6 divided by A. So this here delta B, okay, that vertical, okay, 1268 into 10 to the power 6. This is given A, this is E, right? So once you will divide, you will get 3.52 mm. Once you will just simplify this one, you will get the 3.52 mm. That deflection, but vertical deflection at B as 3.52 mm. Right. Now just see for D, the sum is how much? 880, right? 880. So this divided by A. This not this only 880 into 10 to the power 6 divided by A. So for delta D, this H stands for horizontal deflection, because in question itself it was there, that horizontal deflection, and at B vertical deflection. So delta B at D horizontal, so delta DH 880 into 10 to the power 6 divided by A into E. Once you will simplify this one, you will get 2.44 mm. So see here, the positive value of BB and DH, B that at B vertical deflection, at D horizontal, indicates that the deflection are in the direction of PBF and PDF. Means whatever the direction of PBF you are acting and PDF, in the same direction the force is acting. So means what we have chosen, PBF is downward, right? So deflection is vertically downward, not only the vertical deflection, vertically, because earlier we know the vertical deflection only you have to find. That is either it's a vertically upward or vertically downward. But we are applying force vertically downward PBF, and in the same direction we are getting this deflection is, earlier also I told you that the negative value just showed in which direction. Whatever direction you considered, either it's opposite to that one or same. If you are getting positive, means in the same direction. If getting negative, means opposite direction. So according to this, what we got, this PBF that is positive. So that is vertically downward. So deflection will be now vertically downward. If suppose we got the negative value like minus 5.2 or whatever value you get, minus, means force will act in this direction but deflection will be in this direction. This actual deflection is in this direction. So what we have chosen, the force direction, that is wrong, and force is acting also in this direction. But right now we have, because this PBF is chosen by us, we have applied the force, that fixes force. That can be of any direction. If you wish, you can take in this direction also. Then definitely you will get the negative values, means your direction of force is opposite and hence the deflection is also opposite. Now in that DF, what is there? So in DF also we have taken direction in this one, and in this that positive is coming, means deflection will be in this direction. If suppose we have chosen the direction in this one, then deflection is coming negative, means because deflection will be in this direction, so our direction of force is opposite and the actual deflection will be in this direction. So that's why I earlier also told, don't get confused with the minus and plus. Minus and plus only shows whatever direction you have chosen, that is correct or not. If you have chosen direction and you got the positive value, means your direction is correct, or else force is acting in the opposite direction. If you are getting negative, force is acting in another direction. Same means that positive means whatever your direction is, that direction is correct. Okay, so this problem will take, if you will go solve for solving, right, it will take more than 1 hour, so that you have to practice 3, 4 times, 5 times, right? You have to must thorough with to find the forces in each direction. First, just here again, first what you have to do, first you have to find the reaction forces. Then by using the joint method, as I discussed, take point where only the maximum 2 unknown loads are there, solve for those two, find those two loads, then according to that select the next point, right? There also maximum 2 unknown should be there, find that point, like that. Find forces in each member. So for finding forces itself will take more than 15-20 minutes for all the members, because how many are there? Total 9 members are there, but more than 9 also is there. So this problem you have to practice a lot. This problem is very easy. Just the thing is you have to find a lot of things. Method is all same. What you have to apply? First resolve, consider that point, resolve the force. Sum of vertical force is equals to 0, sum of horizontal force is equals to 0. With that you can find forces in the unknown members. Once you have all the forces, then remove that force, apply the Fixier's force at that point where you want to find the deflection. So here we require to find the deflection at B and D. So apply the forces at B and apply the forces at D. Now find that forces. Once you will have that force, right, differentiate with respect to PBF and PDF, right? Once you will PDF, then what you applied the deflection force, that will get removed. The next step is apply in the formula. So what is the formula? FI by AIEI into del Fi. So but AIEI in this question, it's a constant, means same for all the members. So just we have taken out FI. Fi forces each member, Li length of the each member, that is easy to find. That now mostly it's a given, or it will be given. The only thing is this you have to find. After that, put into the table, then it will be easier. So just see here and here. So this is just the member name. This is length. In that only these three you require to find. Remaining all are directly given. After that, by this from the joint method, once you have, then apply the Fixier's force at that point where you want to find the deflection. So at B it's required to find. So that's why we just mentioned that here, that FBF. So find the Fixier's force in each member again. So here again this will be difficult, or this will be time. Not it will be difficult. This will take time, right? So these two is time consuming, because for each member you have to find. Once you have these two values, after that it's very easy. Why? Because just you have to differentiate. So wherever PBF is there, make it 1. Just differentiate with respect to PBF 1. So directly you can just remove the PBF and you can copy as is whatever is here. Similarly, you have to find then again. So in this table, finding this is easy and very less time it will take, because most of the dimension will be given. So for each member here you have to find, and this you have to find by applying the Fixier's load, and this you have to find. In this case, it's a given horizontal deflection, right? That's why it's there. But what we had seen earlier in the derivation, here one load was there at this point, right? At this point and at this point, or at this point and at this point. Then it will be different. Then it won't be 0 for all this. Then again you have to find for all by the same method. So for finding this and this is, this and this third and fourth column and sixth column will take time. Once you have these three, after that just differentiate, you will get the fifth column, differentiate sixth, you will get sixth column with respect to where the point is there. So here PDF. Once you have, then multiply 2, 3, 5 for deflection at B, because this is for B. So 2, 3 and 5. So and 2, 3 and 7 for D. After multiplying, just add all the values for finding BF also, that is at B, and for D, and just whatever you are getting, divide with the value of A, because A we have taken common according to formula. This only summation we are finding. So this whole value is this one. and for D, this one. Once you have this one, divide by AE. Once you will divide by AE, you will get the answer. And in this case, what we are getting here, 3.52 and 2.44. Both are positive. Means whatever direction we have chosen means deflection is vertically downward because force is acting vertically downward. So the direction is correct. Deflection will be vertically downward only. In this case, we have chosen it's moving right. So deflection is coming positive. So in this case also, this will be right. Right? So from here, this question. So if you have, again, this is the reference. This question you can find in even that Mection book also. So just for your reference, you can refer this book. Right? But in Mection, there is no detail. Directly they given the table and the last two calculations are there. So that's why I explain each and every that member how to find the loads. By the same way, you can find the fixed load also for each member. Once you have the fixed force, that force, then multiply with load, differentiate with respect to PBF for at B and PDF at D. Find, then multiply according to the formula. Just add, divide by E. You will get the solution. Okay. So if you have any doubt, you can just comment on the video. Okay. And clarify your doubt, or you can just contact me. I will clear your doubts. Okay. So but make sure this problem to practice, then only you can solve within the time frame. Otherwise, you can see even for solving itself almost 45 minutes to 1 hour it takes me. Right? So for solving it will take time. So definitely in a starting once you will solve this, don't skip that problem. This is just lengthier but easy problem based on the formula or directly some of vertical horizontal forces you have to do. The only thing is it will take time. So once you will practice that one, then easily you can solve this question within the time frame. So don't only want to know this question is too long or something. Just practice 3-4 times, or after that automatically you can see you can easily solve this question. Okay. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.